There was a time when man understood that within his body there was an indissoluble bond with the universe. From that moment, observing the vastness around him, he wondered if he had ever been alone. Until the creation of artificial lighting, the darkness that surrounded us allowed us to observe the most distant stars with the naked eye. The environment underwent changes that were reflected in our body and our genetics. The continuous determined experience of reality led to a refinement of sensorial and logical abilities. The stimulus caused by our context provoked a response, the need to remind our successors how we had gotten where we were, how we had survived. Many ancient cultures developed a profound awareness of the constellations and their positions, and used them for navigation. The stars became the homes of the gods or spirits of the ancestors, eternally present entities capable of creating moral laws. But the night sky and the unpredictability of the human soul brought about doubts and fears. Myths, legends, and reality merged into stories where spirituality and culture intertwined. Only gradually, thanks to the experience of generations, has it been possible for us to discover the natural mechanisms that surround us, bringing us ever closer to an adherence to reality, until the birth of science, to the point of making us affirm that solitude in this immense space in continuous metamorphosis could be impossible, since space already contains all the elements necessary for the birth of multiple forms of life. There are mysteries that still await an answer, and the answer to the evolution of our species is only just at its beginning. The long and troubled evolutionary path of every living system is full of errors, which over time have been corrected in order to head in the right direction and guarantee survival. A clear example of this comes from the observation of reality through machine learning, one of the many tools of artificial intelligence, capable of making a computer learn a path autonomously. As a demonstration, let's analyze the route that a toy car should take to reach its destination. We enter some parameters into the computer, start the process, and notice that generation after generation of toy cars crash into the many sides of the entire route before reaching the finish line. If we decided at the end of the process to modify some previously inserted law, we would find ourselves having to deal with new generations of toy cars forced to have to learn the original route all over again. In a certain sense, our evolution works just like those toy cars. In reality, of course, the issue is much more complex and also subject to unforeseen events. A clear example of this is the extinction of the dinosaurs, who, between ice ages, meteorites, volcanoes and earthquakes, had to deal with a nature still in the process of stabilization. These gigantic beings did not possess the use of speech and could only follow instinct. We, unlike the dinosaurs, fortunately possess reason, a conscience. Our environment has reached a certain balance, and we possess a very powerful means to predict eventual risks: knowledge. Yet despite this, we still have to learn how to use our abilities in a way that avoids self-destructive actions. Now, you're probably wondering what all this has to do with aliens. If aliens did manage to reach us, their evolutionary path was clearly superior to ours. This could suggest that some instinctual behaviors on the part of these beings may have been excluded, or that the most intelligent life form among them may have prevailed, or that they are beings extremely older than we are. Ideas that then raise more than one reflection. All living beings possess a survival instinct. It is necessary to decide which path to follow to achieve conscientious evolution. If the universe pushed these beings to look for a home elsewhere, they could therefore also no longer have a home to return to. But before continuing, we need to reflect a moment on human evolution and on who we are. First of all, When compared to the universe, the human being is a newborn baby. The universe is approximately 13.8 billion years old, while the Earth is 4.5 billion years old. We, as Homo sapiens, have existed for just 200,000 years, a tiny period compared to the entire chronology of the universe, a perspective that highlights our very delicate presence as a species. We are the result of billions of years of evolution, direct descendants of the stars, incessantly searching for our place in the cosmic infinity. Our identity has been shaped by our incessant curiosity towards the unknown. We are complex beings, endowed with thought, introspection, and creative, but also destructive, potential. Our intelligence has taken us from being simple hunter-gatherers to founders of civilizations, promoters of revolutionary technologies. We live on a tiny blue-green planet in one of the countless galaxies in the universe, and this planet on which we rest our feet, our home, is a very small point in the immensity of space, which travels at around 30 kilometers per second, 108,000 kilometers per hour, in an infinite void. And it is right here that we have reached sublime peaks and faced dizzying descents. Therefore, reflecting on the idea that alien life forms may have reached us, their evolutionary path could differ profoundly from ours. Perhaps they have overcome challenges we cannot even conceive of, or perhaps their environment has not always had more favorable conditions than those in which we live. Only one thing is certain: if these beings have the ability to travel between the stars, arrive on Earth, bend space-time, and remain immobile in the sky with their spaceships, then they have reached levels of technological progress, and probably also of wisdom, far superior to ours. What binds us to these hypothetical life forms, therefore, could be curiosity, the same force that pushes us to scan the sky, to ask ourselves if we are alone. And if one day we were to cross their path, we could discover that, beyond the obvious differences, we share a common aspiration: to understand the reason for all this. In any case, before understanding why the alien question is distant from what we imagine, it is very important to understand how we have faced the dilemmas related to existence and creation, which have always gripped our minds. We need to investigate, starting from the past up to the present day, making a distinction between objective reality and fantasy, between science and myth. The stories that have come down to us that address questions relating to the genesis of man and the universe make us perceive a sense of wonder and fear on the part of our ancestors. The theme of the genesis of life has permeated almost all cultures in the world, many of which have tried to provide answers through popular, religious, and philosophical tales and stories. However, although some of these stories have the ability to generate a strong evocative impact, their rational process, in some cases, deviates from objective reality. To demonstrate this in a logical way, the stories possess similar but never identical characteristics, underlining both a possible ethnic mix of the past and a strong use of imagination. Bear in mind that imagination is not something that generates ideas from nothing, but rather draws from real parameters or those suggested by intuition, to modify them, decrease them, or enhance them. These parameters contained in the stories could therefore have been deliberately altered to generate emotions, find solutions, and invent new things, sometimes with an objective: to awaken memories and thoughts. In fact, all stories about creation share many symbolic elements, such as water, blood, earth, archetypal elements capable of bringing out globally recognized images and thoughts, linked to both life and to creation. These stories do not only speak of battles between divinities, gigantic gods capable of creating everything through dreams, but also of metaphors, that reflect the conception of reality of the many peoples who have lived on the earth. The stories demonstrate a strong need to bear witness to human behavior, to make people understand who we are and who we once were. Our ancestors were looking for a way to bring to the eyes of their successors what had been done up until that point, underlining that we are all continually subjected to the immense and perennial turmoil of internal and external conflicts. Finally, some of these stories have had and continue to have a profound impact on the attitude of the people who created them. Though some have been forgotten or are no longer believed, they remain the only criterion of distinction between what we believed in the past and what we know today about the birth of life, both terrestrial and extraterrestrial. In Australian Aboriginal culture, the concept of the creation of the world is passed down from father to son and plays a fundamental role in society. In addition to creation, these stories contain laws, moral codes, lessons on survival, and denote a deep connection with the land they belong to. Meanwhile, these Australian people see themselves as custodians of the landscape. The responsibility to protect and care for the territory, as their ancestors did before them, is one of the main foundations on which they draw. Creation for the Aborigines dates back to the time of dreams, a period in which gigantic totemic creatures, emerging from the sky and the earth, crossed the planet, singing about what they encountered in their minds: rocks, pools of water, animals, plants. Only through the visions of these beings it became possible to bring the elements of dreams to actual creation. The spirits left traces of their adventures on Earth, and many places in the area are still considered sacred today, due to the connections with these stories. Of the Babylonian creation myth, described in the Enuma Elish, there are various versions and copies, the oldest of which dates back to about 1700 BC. According to the Babylonian myth, Marduk, the son of Enki, faced the titanic battle against Tiamat, mother of all the cosmos, as well as primordial goddess of the oceans and salt waters. In an epic clash, Marduk split the female divinity in two, from whose halves emerged the earth and the sky. Continuing his destructive undertaking, he also struck down Kingu, husband and firstborn of Tiamat. It was only by using Kingu's blood that Marduk created humanity. In the first passage of the Enuma Elish, we read, "When on high the heaven had not been named, firm ground below had not been called by name, naught but primordial Apsu, their begetter, and Tiamat, she who bore them all, their waters commingling as a single body. No reed hut had been matted, no marshland had appeared, when no gods whatever had been brought into being, uncalled by name, their destinies undetermined. Then it was that the gods were formed within them." The Bantu, a vast ethno-linguistic group including over 400 ethnic groups in sub-Saharan Africa, developed between 3,000 and 5,000 years ago. For them, the earth was originally nothing but water and darkness. Mbombo, the white giant, ruled the chaos, but one day he felt a terrible pain in his stomach and vomited the sun, the moon, and the stars. The sun shone brightly and the water evaporated away into the clouds. Then slowly, dry hills appeared. Mbombo vomited again, and this time the trees, animals, and many other things came out. The first woman, the leopard, the eagle, the anvil, the monkey fumu, the first man, the firmament, medicine, and light. Nkienge, the woman of the waters, lived in the east. She had a son, Woto, and a daughter, Labama. Woto became the first king of the Kuba people. According to the Cherokee, a native people of North America, In the beginning, there was only water. All the animals lived above it, and the sky was flooded. The animals were curious about what was under the water, and one day Dionysi, the water beetle, volunteered to go exploring. All Dionysi found, however, was mud, which, brought to the surface of the water, began to grow and expand all around, until it became the earth as we know it. One of the animals hung this new earth from the sky with 4 strings or laces. However, the land was still too wet, and the animals sent the great hawk to Galunlati, the spirit world, to prepare it. The hawk flew down, and when he reached the ground, he was so tired that his wings began to strike the ground, forming valleys and mountains. On that new earth, darkness reigned. The animals then decided to create the sun. In its original position, however, the sun was too close, and a peaceful life was impossible. Some of them then got together and decided to move the sun higher in the sky, where it would provide light and heat, but not be so hot that it would burn everything. The sun was moved to its current position, and when they realized that the distinction between day and night was not clear, the animals decided to create the moon and stars. As time passed, the land became more and more prosperous, and animals were able to multiply. However, they realized that something was still missing: beings who could take care of the earth and of them. Thus, they created human beings. Humans initially did not know how to live. They were helpless, clumsy, so the animals taught them how to hunt, fish, farm, and build shelters. They taught them the laws of nature and how to respect the earth and all its creatures. In return, humans were supposed to honor animals and consider them as brothers and sisters. Over time, humans learned to live in harmony with nature, and the Cherokee civilization was born. Regarding the myths of the Far East, Buddhism normally ignores the question of the origin of life. The Buddha stated that it would be possible to discuss these things forever, without, however, approaching the true goal, the end of suffering. However, a little further away, in China, the myths about the origin of life are treated in 5 main visions. It begins with a statement similar to the Buddhist one, but clearly more categorical, according to which the evidence necessary to explain creation and its origins does not exist. The second vision, very common with others, asserts that heaven and earth in the beginning were a single entity that separated into 2 parts. The third, coming from Taoism, explains to us that the Tao is the force behind creation. Everything was created from nothing, matter was generated from the void, and from this everything was born through different natural processes. In the third and fourth visions, 2 of the main myths are then told, as if from the previous considerations it had been necessary to dispel some thoughts by introducing new nuances. The first, most important myth is that of Pangu. According to this explanation, offered by Taoist monks centuries after Lao Tzu, the universe was born from a cosmic egg. A gigantic deity, Pangu, being born from the egg, broke it into 2 parts with his axe. The upper half became the sky, and the lower half the earth. As the deity grew over 18,000 years, the 2 parts of the egg became increasingly separated, and when Pangu died, his entire body conformed to various areas of the planet. Men were born from the fleas present on his body, while his breath became wind and clouds. His eyes transformed into the sun and the moon, his hair and beard into the stars and the Milky Way. The echo of his voice resounded through the centuries through the thunder. His sweat bathed everything as rain. His angular limbs solidified into mountains. His veins became rivers, and his muscles a fertile, earthy layer. His bones and teeth became precious minerals, such as metals and gems. The fifth vision includes some tribal tales, and there is no single tale. But in one of these, the best known, Nuwa is spoken of, a being with the body of a serpent or dragon and the head of a woman. After the world was created, Nuwa, feeling alone, decided to create humans. She used yellow clay to model the first figures. She began carefully, but then, tired and nervous from the laborious process, she became impatient. By splattering the clay with a whip, the drops of clay became people. It is said that those she had carefully shaped became the nobility, while those formed from the clay drops were the common people. In the Bible, God created the world, meaning the universe, in 6 days, resting on the seventh. Some Christian doctrines teach us that these are literal days. Others believe that the term day should be understood as creative ages, lasting thousands if not millions of years, as the translation from Hebrew leaves ample space for interpretation. In any case, the Catholic Church today suggests a metaphorical and non-literal reading of the text, although over the centuries it has demonstrated a strong propensity towards an absolutist vision of the texts, and there is no single version of them. In Genesis, one of the sacred stories for Jews and Christians, but also recognized in a different way in the Muslim Quran, opens with the following words: "In the beginning, God created the heavens and the earth. Now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters." Since the origins of Western philosophy, especially among the thinkers of ancient Greece, the question of the origins of the cosmos and of life occupied a central position, but very distinct from myth or religion, which, moreover, contributed to trying to understand the issue with a slightly more analytical spirit. The different philosophical schools were divided between those who identified the origin of the universe in a single fundamental principle, such as water, logos, or being, while others saw reality as emerging from a combination of elements or forces. In his poem on nature, Parmenides argued that the multiplicity and changes of the physical world are illusory and stated, contrary to common sense, that reality is being. Immutable, ungenerated, finite, immortal, unique, homogeneous, immobile, eternal. For Parmenides, therefore, what truly exists is only being, and non-being or emptiness, nothingness, could not exist at all. This conception is diametrically opposed to the thesis formulated by Heraclitus, according to whom the whole world is nothing but a perpetually evolving flux, in which no thing is ever the same, since everything is transformed in continuous evolution. Although Heraclitus's philosophy has come down to us in a fragmentary way, he seems to anchor reality to time and to the continuous transformations that it entails. For him, only change and movement are real, and the identity of things is illusory, that is, everything flows, or pantarei. Even the Democritean atomists opposed the concept of immobilism, and they did so with a semi-scientific theory that was highly intuitive for the time. Introduced by Leucippus and further developed by his student Democritus, the atoms, eternal, immutable, presented themselves in various shapes and sizes, moving in an infinite void and combining in various ways to form objects and substances of the visible world. It was precisely the movement and aggregation of atoms in the void that gave rise to the diversity of things on our planet. The concept of non-being, represented by the void, was essential to atomistic theory. Without the void, the atoms would not have had space to move, and therefore there would have been no possibility of combinations and interactions between them. In this sense, being, the atoms, and non-being, the void, coexisted and were both necessary for the formation of the universe. In short, a vision similar to Lao Tzu's Taoism, although atomism was a theory on the physical nature of reality, while Taoism was a spiritual and religious philosophy. In the theory developed by Anaxagoras, however, life on Earth would have developed following the scattering of seeds present throughout the universe, harmonized by a nous, a sort of divine intelligence. This hypothesis, considered at the frontier of science, was taken up in a more objective way in the 19th century and renamed panspermia, a Greek term meaning common seed. But we shall discuss this later. The Greeks' reflection on the nature of reality then developed significantly with the Sophists and reached its peak with Plato and Aristotle. According to Plato, the physical world was modelled by the demiurge, a divine craftsman who was inspired by the eternal and perfect world of ideas to bring them to the imperfect world of things. Note here the similarity with the myth of the Cherokee. Aristotle, in contrast to Plato's theory of ideas, instead conceives a universe where everything has a purpose, introducing the concept of final cause. According to him, every natural entity can be explained through 4 different causes or explanatory principles. Each of these causes is linked to a material or substance subject to change. The 4 causes, called material, formal, efficient, and final, can be illustrated as follows. Taking a statue as an example, the material cause would be the bronze or marble it is made of. Formal cause would refer to the design or concept that makes an object what it is beyond its mere material composition. For the statue, the formal cause is not only its visible form, but also the idea or design that the material represents, such as the representation of a god or a hero. The efficient cause concerns the agent or mechanism that induces a change. In the statue example, the efficient cause is the sculptor. Final cause indicates the purpose or function of something. In the context of the statue, it could refer to the desire to adorn a place or to express beauty through form. For Aristotle, the final cause is not always an external entity or an abstract idea, but is often inherent in the very nature of the entity itself. For example, the final cause of an acorn is to become an oak tree. It is not just a purpose imposed from the outside, but it is what the acorn, by its nature, tends to become. Aristotle therefore argued that everything in nature had a purpose or function. Being has a reason why it exists, and its final cause is that reason. The final cause is the realization of its intrinsic potential, what it was created for, but also what it aspires to become. About 2 centuries later, Cicero, influenced by Greek philosophy, stated in his Tusculan Disputations that the world never had its origin, since there was no beginning for the arrival of a new decision of such an excellent work. A statement that we are currently studying through quantum physics, but analyzing the universe and not our world. According to a recent theory, in fact, the Big Bang would not be the origin of our universe, but only an event in the evolution of something that has always existed. In short, the mind of individuals in the past and present, as well as the reality in which we live, is multifaceted and capable of extrapolating a large number of thoughts and further questions, with each answer uncovered. However, although the origin of life has been explored extensively throughout history, offering some futuristic, ingenious, and highly intuitive food for thought, the answers provided have never been completely exhaustive. Only with the advent of scientific thinking have we broadened our horizon of knowledge, getting even closer to the mysteries of life in an objective and evidence-based way. However, this knowledge represents only a part of what we could define as reality. If there is no single defined reality, since such an existence would suggest a single interpretation of how events may have developed, then the doors open to infinite possible visions, each of which can be potentially shaped, even by different scientific interpretations. This concept implies that while we can universally recognize some parameters or fundamental laws and elements, events and phenomena can manifest themselves through a wide variety of different processes, leading to multiple outcomes. In any case, the more science has continued its progress in the search for an objective truth about the origin of life, the more the literal narratives of religious texts have become the subject of debate. The debate has provoked a gradual conceptual metamorphosis of reality itself, which has led many people to consider sacred texts in a less literal way. Only in this way was it finally clear that the main intent of the religious texts was not to provide a scientific account of the origin of ours and other lives in the cosmos, but rather to give meaning and purpose to human existence. Then, if some of the figures who enrich these stories were real or not in the past, we must not let ourselves be influenced in a paranoid way on the issues. We live in the here and now, and the only correct thing, if not probably necessary thing to do, is to collect and study many of these stories for comparison. It is therefore true that science is very important for the search for objective truth. But the power of religious storytelling lies in its ability to touch profound and universal aspects of human experience, providing meaning and direction in ways that go beyond pure logic or analytical reasoning. While on the one hand, science tries to explain the world through observations and theories, religions interpret it through myths and symbols, proposing an existential understanding of the human soul. In the intersection of these two approaches, tensions emerge, but also potential synergies. While science can challenge or disprove literal interpretations of sacred texts, it cannot necessarily disprove or replace the profound spiritual or moral meaning that such narratives can bring to an individual or community. On the other hand, religions, while providing profound answers to the mysteries of existence, must also face and adapt to changes in our knowledge and in our understanding of the world, brought forward by science. In the continuous interaction between science and religion, therefore, humanity seeks a path between the discovery of tangible truths at the extreme borders of knowledge and the intrinsic need to find meaning and purpose in a cosmos as vast as it is enigmatic, creating profound connections, both emotional and spiritual. Only in this way will we realize that the real key could be to find a balance and harmony between science and religions, remaining open to knowledge. Logic and emotion both play an essential role in how we perceive and interact with the world. Logic gives us excellent tools to understand, influence, and improve the external world, while emotion provides us with meaning, direction, and the ability to connect deeply with others. Ideally, we should aspire to nurture, enhance, and respect both of these two dimensions of our lives. In our century, however, there already exists a link that tries to unite faith and science. This link tells of extraterrestrials, a topic that as we move forward is increasingly taking shape through all-encompassing research capable of dismantling the known world. What science has then discovered about possible extraterrestrial life forms goes beyond any form of imagination. In the eyes of science, the question of the origin of life is much more complex and fascinating. Specifically, the field of study that over time has been concerned with determining how this occurred is called Abiogenesis, a Greek term meaning non-biological origins. Abiogenesis is an interdisciplinary subject of study that includes molecular biology, paleontology, astrobiology, and biochemistry, and which seeks to understand how the first life forms developed from primary abiotic chemical processes. Life on Earth would have subsequently evolved thanks to the interaction between non-living organic molecules capable of forming complex chemical bonds through carbon and inorganic molecules such as water and hydrogen. The combination of these elements, together with energy factors such as solar radiation and geothermal sources, would have catalyzed the chemical reactions necessary for the formation of the first relevant biological molecules. The transition from a non-living system to a living organism would therefore not be attributable to a single factor, but rather to a gradual increase in system complexity, starting from the birth of the universe, estimated at approximately 13.8 billion years ago, up to the present day. The high number of chemical elements present in space would have generated a high number of reactions over billions of years, which in more or less favorable contexts and destined to stabilize, would have led to the birth of the ancestors of many living species, that is, microbes. The period referred to for the origin of terrestrial life, however, is between 4.4 billion years ago, when water began to be in a liquid state, and 2.7 billion years ago, a period of which we have the first irrefutable evidence. The evidence to date is provided to us by stable isotopes and molecular biosignatures, with which we can respectively determine information on past environmental conditions, and the chemical imprints left in the rocks by the passage of microorganisms. The remains in fossil form found in the green rocks of Isua in Greenland, for example, are direct proof of the existence of life forms in a period in which the Earth was chemically different from how we know it today. A hostile and volatile world with a dense, oxygen-free atmosphere, warm, mineral-rich seas, frequent volcanic eruptions, and meteorite impacts. Another example comes from a recent study that analyzed hematite filaments present in samples taken from the Nouveau-Agetuk supercrustal belt, dating them between 3.75 and 4.28 billion years ago. When hematite interacts with microbes, it can form filament-like structures that scientists can translate as fossil footprints. If the study were confirmed, it would be proof that the formation of life on Earth occurred very quickly following the cooling of the crust. But let's analyze how the first foundations on this research were laid. In 1668, it was still thought that insects were formed thanks to a process called spontaneous generation, the widespread belief from antiquity until the 17th century, according to which life could arise in a spontaneous way from inert or inanimate matter and through the effect of what were called vital flows. At the time, in many cultures, it was believed that God had directly created only superior living beings, such as man and large animals, while inferior ones, such as worms and insects, could arise spontaneously from mud or rotting carcasses. In this regard, the chemist Jean-Baptiste van Helmont even went so far as to provide the following recipe for the creation of mice. If you place a sweat-stained shirt or piece of linen in a container together with some grains of wheat, after about 21 days, the ferment of the sweat coming from the shirt transforms the wheat into live mice. But these mice will not be completely normal. They will not have complete reproductive organs and will only be able to reproduce if they are accompanied by other mice generated in the same way. This anecdote about Jean-Baptiste van Helmont clearly illustrates how the prevailing ideas of the time were significantly different from our understanding of biology and the world today. What may seem absurd or naive today was at the time an accepted explanation of reality and fully conditioned by popular beliefs. The theory of spontaneous generation was then questioned by some experiments performed by Francesco Redi and Lazzaro Spallanzani. In 1668, Francesco Redi conducted a study strictly using the experimental method. He placed pieces of meat in several glass jars. Some of these jars were deliberately left open, the experimental group, while others were hermetically sealed, the control group. As a result, the scientist obviously noticed that in the open jar larvae and flies could appear, while in the sealed jar these organisms did not develop. To confirm his results, Redi then decided to conduct another test, where the jars of the experimental group, the originally open ones, were closed with gauze, thus allowing air to circulate inside the container but preventing access to insects. In this way, he noticed that the flies attracted by the meat were unable to reach it. They attempted to lay their eggs through the gauze, but were unable to get past it. As a result, neither larvae nor flies appeared inside these jars, and Redi was able to demonstrate that spontaneous generation was not all that possible. As the years passed, the theory was gradually abandoned. However, the advent of the microscope led to a general revival of studies. Other previously unknown life forms were discovered, such as fungi, bacteria, and protozoa. In fact, it was noticed that it was enough to put decomposing organic substances in a warm place for a short time, and strange, living beasts appeared on the surface. In the mid-18th century, John Turberville Needham, starting from the observation that microorganisms grew luxuriantly in various soups, obtained from the infusion of meat or vegetables and exposed to the air, concluded that within all matter, including air and oxygen, a vital force was present, responsible for spontaneous generation. To support this thesis, he boiled some of his infusions for a few minutes, in order to eliminate any contaminating microbes, and poured the liquids into clean flasks, closing them with corks. Day after day, he observed the growth of microorganisms and believed that spontaneous generation was possible. A few years later, in 1765, Lazzaro Spallanzani, skeptical about Needham's conclusions, conducted similar experiments, but with further variations. He boiled his infusions for an hour, then sealed the flasks. The result was a sterile compound which even after several days showed no growth of microorganisms. As a control group, he used a compound heated only for a few minutes and left open to the air, finding that in this case the growth of microorganisms was possible. In the third group, he boiled the mixture for an hour but closed the containers with corks, thus allowing air access, and obtained the same result as the control group. Spallanzani saw in this way that while an hour of boiling sterilized the mixture in the sealed jar, a few minutes were not enough to do so. Needham then replied that prolonged boiling could destroy the vital force necessary for spontaneous generation, while a brief boil wasn't enough to destroy it. Sealed containers could block the life force, while open ones could not. When the controversy became too lively, the Paris Academy of Sciences decided to offer a prize to anyone who was able to shed definitive light on the subject. In 1864, Louis Pasteur finally managed to disprove the theory. This time, the experiment no longer involved the use of a normal flask, but rather a gooseneck flask, a special ampoule equipped with a curved neck, which allowed oxygen to enter but avoided direct contact with contaminating agents such as spores and bacteria. After sterilizing the broth with long cooking in one of the flasks, Pasteur eliminated all life forms within it. Noticing that no microorganisms were growing, the man then decided to break the glass neck to expose the broth to the outside air, and began to notice the appearance of small organisms. The central point of the scientists' experiments was to demonstrate that air was not the vital force for spontaneous generation, but rather the means of transporting bacteria and spores, and that these, in turn, were directly responsible for the apparitions on the surface of the organic material. With this experiment, the man definitively rejected the theory of spontaneous generation, and, as he himself proclaimed in a conference at the Sorbonne in Paris, the theory of spontaneous generation will never be able to recover from the mortal blow inflicted on it by this simple experiment. Although the theory of spontaneous generation was refuted in 1864, already starting from 1858, the roots of abiogenesis began to make their way into history, with some interesting considerations. The first concerns the theory of evolution by natural selection, formulated independently by Alfred Russel Wallace and Charles Darwin. The theory suggested that all life forms are linked by relationships of common descent through branched phylogenetic trees, all leading back to a single progenitor. Extremely simple from a biological point of view. The problem, however, was to understand in which context this simple primordial form of life could be structured. For scientists, it could presumably be a cell very similar to modern prokaryotes, that is, simple cells without a cell nucleus delimited by a membrane and whose genetic material, DNA, swims free inside the cytoplasm. Prokaryotes are tiny, ubiquitous organisms, which means they can be found in almost all terrestrial environments, and they perform essential ecosystem functions. They actively participate in the decomposition of organic matter, the production of oxygen through photosynthesis, and much more. If we were to describe them in a simple way, we could define them as the invisible scavengers, responsible for the transformation cycles of terrestrial matter. The second observation comes to us from a letter to Joseph Dalton Hooker, dated February 1st, 1871, where Charles Darwin advances a hypothesis, directing attention to questions that would involve a large number of scientists. He suggested that the initial spark of life may have occurred in a small and warm pond containing ammonia, phosphoric salts, light, heat, electricity, etc., so that a protein was chemically produced, ready to undergo new and more complex changes. He then went on to underline that today such matter would be instantly devoured or absorbed, which would not have happened before the formation of living creatures. The terrestrial environment is so pervaded by life, therefore, that any potentially analyzable prebiotic molecule would be rapidly consumed by other microscopic organisms, which makes it extremely difficult, if not impossible, to observe any form of abiogenesis in a natural environment. In other words, the presence of life itself makes the search for its origin dependent on the sterile conditions of the laboratory. Scientists nowadays rely on simulations where they can recreate the hypothetical conditions of the primordial Earth, but an initial experimental approach to the question was beyond the possibilities of science in Darwin's time. No real progress was made until 1924, when Alexander Ivanovich Oparin realized that it was the lack of atmospheric oxygen that preceded the chain of events that would lead to the evolution of life. According to Oparin, the catalyst for the first living forms was a strong presence of ultraviolet radiation, which, if oxygen had been present, would have been promptly shielded by the formation of ozone. In short, Oparin understood that ozone was capable of forming a shield, although he was not the direct discoverer of the process called photolysis, where oxygen is transformed into ozone. In any case, the mechanism he hypothesized was explained in the publication entitled The Origin of Life on Earth, where the scientist underlines that in an oxygen-poor atmosphere and through the action of sunlight, organic molecules could have found a better context to multiply. The generations of molecules would then be strengthened through their slow mutation, accumulating in a primitive sea called primordial soup. These organic substances would have combined to form increasingly complex molecules until arriving at coacervates, droplets similar in appearance to current cells. The coacervates, growing by fusion with the other drops and reproducing through the division into child drops, would have constituted a primordial metabolism where those factors that promoted cellular integrity could be maintained, while on the contrary, others became extinct. Many modern theories on the origin of life keep Oparin's idea as their starting point. In 1953, two scientists, Stanley Miller and Harold Urey, influenced by both Darwin's and Oparin's ideas, decided to conduct an experiment to test some of these theories and their variations. They recreated in the laboratory the conditions that were believed to characterize the primordial atmosphere of the Earth, with hydrogen gas, methane, ammonia, and water vapor. Subsequently, they bombarded this mixture with electrical discharges, simulating the energy provided by lightning. At the end of 7 days, the solution surprisingly produced amino acids. We will try to explain to you what amino acids are in an extremely simple way. Think of amino acids as building blocks. Each brick has special parts, specific chemical groups called amino group, composed of nitrogen and hydrogen, and carboxyl group, containing carbon, oxygen, and hydrogen. One group has bumps, while the other has indentations. These structures allow amino acids to join together in precise sequences, forming a protein. Now, when you build something with these kinds of blocks by following a manual, you are told exactly where to put each piece. In our body, the instruction manual is provided by DNA, which encodes the exact order in which amino acids must connect to each other to form proteins with specific three-dimensional structures and precise functions. These structures are fundamental for proteins to carry out their tasks correctly. Some, thanks to their shape, can neutralize germs. Others are essential for the movement of muscles, while still others act as messengers, transporting vital information to the interior of the organism. It should be emphasized that although the Muller-Urey experiment represented a milestone in understanding the possible origins of life, it did not demonstrate how life actually began on our planet. Rather, it provided a demonstration of one potential way this could have occurred. Precisely for this reason, after the 1950s, there was a growing interest in designing experiments like this. In 1961, for example, at the University of Houston, researcher Juan Oro conducted a similar experiment, but with a few more essential considerations. He focused on hydrogen cyanide, a colorless, volatile, and notoriously toxic liquid. His decision to use this chemical compound was no coincidence. It was consistent with the hypothesis of the reducing atmosphere of the primordial Earth, since hydrocyanic acid is obtained from the combustion of materials rich in carbon and nitrogen, two elements highly present in that type of atmosphere and fundamental to the origin of life. From this experiment, Oro not only detected the presence of amino acids, but also abundant quantities of adenine, a nitrogenous base, both present in ATP, a molecule that cells use as an energy fuel, and in nucleic acids. To be clear and concise, the information in DNA is encoded by nitrogenous bases. Adenine is one of these bases. The others are thymine, which in RNA is replaced by uracil, cytosine, and guanine. These bases form the specific genetic sequences of DNA and RNA. In subsequent experiments, inspired by those of Oro, it was then demonstrated that it is possible to obtain other nitrogenous bases and that hydrocyanic acid, under certain conditions, can interact to form various compounds, including cyanogen and cyanoacetylene. To date, it is known that cyanogen is contained in some comets. When these approach the Sun, the heat can cause the release of the gas, contributing to the formation of their typical tail. Cyanoacetylene is one of the many organic compounds that have been detected in interstellar space, especially in molecular clouds, where molecules and atoms can interact with each other. By exposing these particles to energy sources such as stellar radiation, new chemical compounds can form, and accumulations of gas and dust can also give rise to new stars and planets. Research on the origin of life in more recent times has therefore produced various theories that go beyond the classic notion of primordial soup. Some of these propose environments rich in iron or sulfur rather than based exclusively on carbon, but also environments with preponderant quantities of silicon. It has also been suggested that the environments in which life initially emerged may have been highly acidic, in contrast to other theories that postulate neutral or alkaline environments. This variety of hypotheses has stimulated a very high number of studies which have been analysed through the aforementioned practical experiments, but above all also through mathematical models, with which it is possible to help predict and understand the dynamics of the reactions, but also how these might have led to the emergence of life. For example, an intriguing hypothesis analysed with a mathematical model in recent times would involve hydrogen peroxide. Although generally considered a neutral chemical substance, hydrogen peroxide can possess both acidic and basic properties depending on the conditions. Its versatility may have given it a crucial role, both as a solvent replacing water and as an active participant in chemical reactions. In particular conditions, hydrogen peroxide can also decompose through the process of radiolysis, where the molecules of the elements are broken down by radiation, producing oxygen molecules and potentially contributing to the creation of favourable conditions for the development of life. Regarding Jupiter's moon called Europa, for example, the presence of hydrogen peroxide was found on the basis of astronomical observations. One of the most relevant studies in this field, published in 2013, was based on data collected by the Hubble Space Telescope. The spectroscopic analysis of the light reflected on the moon suggested the presence of hydrogen peroxide, raising interesting reflections. The possible existence of conditions that could support life on other celestial bodies in our own solar system. This suggests that we shouldn't rule out any possibilities when it comes to understanding the origin of life. Environments that may now seem hostile may actually have offered the ideal conditions for the first chemical reactions that led to biological complexity and beyond. Scientists who have used mathematical approaches to explore how networks of chemical reactions can self-organize into metabolic cycles have observed that under certain conditions, the emergence of a simple metabolism may be a natural and inevitable phenomenon. According to the aforementioned panspermia theory, the seeds of life, herein understood as simple organic compounds and microorganisms, could be spread through the universe and potentially transported from one celestial body to another through stardust, meteoroids, asteroids, comets, planetoids, and even via spacecraft through unintentional contamination. In the recent mission that took place in 2023 with NASA's OSIRIS-REx, for example, we had the opportunity to recover samples from the asteroid Bennu, showing through preliminary analyses the presence of organic molecules such as carbon and inorganic ones such as water on its surface. Comets and meteorites are also generally covered with external layers of dark material, believed to be similar to tar, and often made up of carbon compounds, which have undergone reactions mainly due to ultraviolet radiation. These discoveries, therefore, lead us to think that various wandering stars in general could have provided the Earth with some of the fundamental substances for the origin of life, and that if these reached our planet, they could also have done so elsewhere. It is also interesting to note that adenine and other organic compounds have also been found in meteorites that fell to Earth in recent times, suggesting that some of these may actually form in space and then be transported to other celestial bodies. One of the most famous meteorites in this context is the Murchison meteorite, which fell in Australia in 1969. Detailed analyses of this meteorite revealed the presence of a wide variety of organic compounds, but what makes the Murchison meteorite still more interesting is that some of the amino acids found in it are not present on Earth, suggesting that these amino acids were formed in an extraterrestrial scenario. Consequently, in recent times, there is growing interest in the observation of extrasolar planets, or exoplanets. The search for life on these planets focuses mainly on the presence of liquid water, an element considered essential. However, the physical dynamics of these environments differ markedly from those present on our planet. Here, the presence of water in liquid form does not depend exclusively on the energy received from a star like our Sun, but on other mechanisms. In these planets, the temperature necessary to activate the processes linked to the melting of ice and the birth of microorganisms could also derive from the energy generated by the gravitational force. These mechanisms occur, for example, in ice satellites such as Europa, one of Jupiter's moons, or Enceladus, one of Saturn's moons. In fact, it is believed that thanks to the tidal forces generated by the proximity to their mother planet, these satellites can experience a subsurface thermal rise, such as to allow the internal melting of the ice and guarantee the presence of liquid water under a thick blanket of ice. The continuous variations in the gravitational attraction exerted by the mother planet stretch and compress the satellite, causing internal deformations and producing heat due to the friction between the particles. Space missions, such as those of the Voyager, Galileo and Cassini series, have recovered further data, which has helped to better understand these phenomena and to attribute the geological activity of some satellites to tidal heating. Various space missions were also carried out on the Red Planet in order to verify the presence of elements necessary for the development of life. Traces of hematite have been found on Martian soil, a mineral which in this case could indicate a preponderant presence of water in the past. The Opportunity rover then obtained images which demonstrate that in the ancient past water could exist in a fluid state on the surface of Mars, showing ancient riverbeds, islands that arose within them, evidence that suggests the presence of a liquid capable of outlining the characteristic formations on the ground. But as the magnetic field decreased, the solar wind could have swept away the primitive atmosphere, drastically decreasing the pressure and almost completely eliminating water from the surface. In December 2006, Mars Global Surveyor provided further photographic evidence, which demonstrated that water still escapes from cracks, leaving deposits on the ground. While in 2011, NASA's Curiosity rover discovered that Gale Crater, the Martian territory where the probe landed, was once a freshwater lake, and it identified organic compounds such as chlorobenzene in the soil. Chlorobenzene is a molecule that contains carbon. This discovery was significant because chlorobenzene is not a compound one would expect to find under abiotic conditions, suggesting that there may have been some form of organic chemistry on Mars in the past. 7 years after the discovery made by the Curiosity rover, ESA researchers announced that the MARSIS radar of the Mars Express probe identified in the subsoil of the Martian South Pole what is probably a frozen lake in liquid form up to 20 kilometers wide and with a depth of approximately 1.5 kilometers. The lake, as detected by MARSIS, is located in a particularly cold region of Mars, where surface temperatures rarely exceed -68 degrees Celsius. This has raised questions about how water can remain liquid under such conditions. A possible explanation could be the presence of dissolved salts, which would lower the freezing point of water, allowing it to remain in a liquid state even at very low temperatures. The results obtained from the various missions have therefore stimulated further research on Mars, as water could provide a vital resource for astronauts, helping in the production of oxygen and fuel. But that is not all. It is hypothesized that Mars, thanks to its smaller size compared to that of the Earth, cooled in much less time, and that therefore the first forms of microscopic organisms could have formed in older times than on our planet, with a difference of hundreds of millions of years. In short, the red planet could have been the perfect incubator planet of life, both as regards the theory of panspermia, but also for the theory of exogenesis, according to which the first life forms would have formed on other planets and celestial bodies, and only subsequently brought to Earth thanks to meteorites. The exogenesis hypothesis does not actually answer the question of how life originated. It simply shifts the question to another planet. Although the evidence supporting the plausibility of the concept is scarce, it is demonstrated in the study of Martian meteorites discovered in Antarctica, in studies on extremophile microbes capable of resisting extreme conditions, and in the results of resistance experiments to space radiation exposure for some terrestrial lifeforms, such as lichens. Further support for the extremophile hypothesis comes from the recent discovery of an extremophile bacterial ecosystem called Desulforodis audaxviata, and whose energy source is radioactivity. The rather surprising discovery of these microorganisms occurred on Earth, in some South African gold mines located over 2 kilometers below the surface. In short, with the discovery of a growing number of exoplanets and the analysis of conditions on celestial bodies in our solar system, the possibility of the genesis of life seems increasingly plausible today. This is why scientists are looking for signs and evidence of advanced civilizations through tools such as SETI, the search for extraterrestrial intelligence. An interstellar journey to visit another civilization on a distant world, at least for now, is beyond the technological possibilities of human civilization. However, we are able to use very sensitive receivers to search the sky for possible radio signals of artificial origin generated by extraterrestrial civilizations, but also to observe unusual events on planets close to ours from different types of telescopes. A final example in this regard comes from an observation made in September 2020 by a team of astronomers who announced the discovery of phosphine in the atmosphere of Venus. This was thanks to observations made with the James Clerk Maxwell Telescope, JCMT, in Hawaii and the Large Millimeter-Submillimeter Array, ALMA, in Chile. Phosphine is a gas that, on Earth, is produced mainly by living organisms in the absence of oxygen, such as some microorganisms in swamps or in the intestinal tracts of animals. What made this discovery so intriguing is that the researchers could not identify an abiotic or non-biological process that could produce phosphine in the quantities observed in Venus's atmosphere. However, there are some important considerations to keep in mind. The surface of Venus is extremely hostile. It is hotter than the surface of Mercury, with temperatures reaching 467 degrees Celsius, 872 degrees Fahrenheit, and has an atmospheric pressure 92 times higher than Earth's. However, Venus's upper atmosphere, where phosphine has been detected, has more moderate temperatures and pressures, and could potentially harbour microorganisms. Scientists have thus established that phosphine can be produced by living organisms on Earth, but there may be processes not yet understood or identified that produce this molecule on Venus abiotically. The discovery of the so-called aliens from Nazca in 2018 and reproposed in 2021 has sparked international fervour, attracting the attention of both the public and the scientific community. These remains, found near Nazca in Peru, have raised many questions regarding their origin and authenticity, yet analyses of them have been able to surprise us. First of all, radiocarbon dating was one of the first techniques used to attempt to establish the age of these finds. This method, based on the decay of carbon-14, allows us to determine the age of organic remains up to tens of thousands of years ago. Thanks to a hand found among the aliens' bodies, some bone and skin samples were taken and analysed, reporting an interesting anomaly. Although the dating of the hand has generally been indicated by almost all media as pre-Columbian in age, around 1400 years ago, according to complete analyses, only the dating of the bone would lead back to that period. The skin sample, however, would be approximately 6,190 years older. This raised suspicions about the use of some substance for embalming, but there were differing opinions on the matter. Another fundamental aspect of the research was the histological analysis of the skin. Through macro and microscopic examinations and by observing the absence of cuts or other modifications, scientists have excluded any type of manipulation that could lead it to being fake. The highly keratinized structure of another skin sample determined that these beings were most likely hybrids, halfway between human and reptile. The absence of sweat glands and mucous membranes would suggest that these beings may have lived in extremely dry environments more easily. DNA analyses underlined that these aliens, in addition to being all male, were in reality Homo sapiens. The antiquity of the bodies, however, has caused a deterioration and loss of genetic information from approximately 50 to 80%. The lack of a comparison sample to determine whether the DNA is extraterrestrial or not makes it impossible to confirm or deny such origins. Even the metal implants on the bodies of those we will call the Greys have been analysed and indicated as being of pre-Columbian age, both due to the choice of alloys and their processing. The ring implant was composed of an alloy of iron, carbon and chromium. The plate found on the chest of one of the Greys would actually be made of a composite material of carbon, oxygen, silicon, sulfur, chlorine, calcium and copper, elements present in various stones with purifying or protective powers for crystal therapy, for example. The hand also has a golden circle on its back. The metal circle appears to have literally transferred to the surface of the skin and contains materials such as gold and silver. In short, based on the conclusions of these analyses, it is clear that there are limits, even for science. However, we still have one key: believing that one day we will be able to see that fundamental reality on which our existence and that of all other life forms rests.